Hello, this is the kickoff presentation for Improving Hazardous Materials Right Sizing. I am Paul Barger. I am the project manager for this project, and I will be taking you through the slides today. If you have any questions as we go through, I ask that you would notate them, write them down, and I'll be giving my contact information towards the end of the presentation. And I am glad to answer any questions you have. Our company purchases quite a bit of hazardous material from different manufacturers, and those manufacturers use different containers that are convenient for them for storing and transporting the material. Our problem is that these materials, the material containers, don't always match our usage on the floor, leading to inefficient and inaccurate material use. If the container size is too small, we use more than one container. That's inefficient. And if the container size is too large, we have material left over after application that essentially is hazardous waste at that point. Here we have our list of stakeholders in the project. Starting with supplier management, we have managers and senior managers, leaderships. They will control the contracting efforts that the new materials that are in the new containers are going to. Operations have day-to-day interaction with the actual materials and applying them to the aircraft. Engineering controls which materials are used as well as what sizes are used. Miscellaneous functions include environmental health and safety, quality, the hazardous material techs that get rid of the material once it's no longer useful, and distribution techs who deliver the product to the point of use locations. Also including program managers that have to make the final decisions for their individual programs, as well as suppliers. They have quite a bit of effort in this project to modify the packaging that their materials go into. The proposed solution to our problem is to undertake an optimization effort to right-size each hazardous material container to fit each assembly application. This will result in maximization of utilization and minimization of excess waste. Another solution that will come from this project is a streamlining of the process of the modification of the container sizes for future efforts. The timeline for this project is laid out in weekly increments starting this week, September the 4th, and ending finally in June of 2018. You can see that the critical path throughout the project is highlighted in red. The very first step is the kickoff project presentation that I'm recording for you now, followed by engineering review, and then contract modifications from supplier management, and then modifying the packaging at the suppliers. And that's really the longest element within the timeline. The task duration is in the third column, and the modification of the packaging itself at the suppliers takes about 12 weeks. After suppliers deliver the product, it's reviewed by EHS and signed off and delivered to the floor, at which point every product is reviewed to make sure that the packaging is in fact right size for its application. And then we've added an additional iteration of that process starting in January of 2018 and lasting till June of 2018. Communication plan that we've created for this project is visually represented in the chart on the left. from the bottom left of the chart to the top is increasing levels of power that these functions have over the project, and from left to right is increasing levels of interest that these functions have in our project. The functions that we've color-coded as green, we believe, are probably going to be champions of the project. The yellow functions, we believe, are going to be neutral towards the project. And the functions that we've indicated in red, we believe, may need additional motivation to help support the project. The functions in the top left quadrant of the chart with high levels of power and relatively low levels of interest will receive customized briefings on status and on an as-needed basis. Functions in the lower left quadrant of the chart with both low levels of power over the project and low levels of interest in the project will only receive occasional status updates. The functions in the upper right quadrant have both high levels of power and interest over the project, and therefore we'll pay close attention to them and they will receive customized communication from us. And finally, in the bottom right quadrant with low levels of power over the project but high levels of interest, we'll receive lots of status updates at each step along the way. An often missed but important part of a project plan is the human resource plan. Our plan includes a project manager for oversight, supplier management for contract modification, operations for consultation, engineering for both the BOM review and modification and consultation, EHS for consultation, and supplier, although the hours spent at the supplier are non-company resources, they're still significant and deserve our attention. Total project totals are between 135 and 180 hours total required for this project. Another often overlooked element is the risk management plan. It's used to identify as many risks as possible for preparation and is updated along the way as needed. Currently on our risk log are elements like the timeline being too optimistic, scope creep, other priorities from team members competing for the project, and lack of sponsor commitment. As promised, here is my contact information as the project manager. I'd be happy to answer any of your questions or concerns regarding the project. In closing, I'd ask that you would seriously consider the inherent value of this project. These materials are not only expensive, many of them pose serious health concerns for human safety. Having containers for these hazardous materials that are the right size for each application not only increase efficiency, which translates to the bottom line, but also reduces hazardous waste and reduces risk to the company's employees. Thank you for your time. Have a great day.